Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 1 and our main topic is on applications of differentiation in the stationary points or turning points or critical points or extrema. So to begin with, what do we mean by a turning point? So we can write this. We take note that a turning point, it is a point on the curve y is equals to f of x, where the slope, another name for slope is gradient, where the slope or gradient is 0. That is what we call a turning point. So when you talk of the slope, it simply means that dy over dx is equals to 0 at any turning point. So there are three types of turning points. There are three types of turning points. The first one is what we call a maximum point. Another one is a minimum point. And the third one is a point of inflection. Let me sketch a curve to illustrate those 3 points. I am going to sketch it here. We sketch a graph of any given function to illustrate the turning points. So here we have x, here we have y-axis, and where they meet is the origin. So I'll come up with any graph. Let's say we have this kind of a graph. We have it was sloping, continues to slope, it goes up, then comes back down like that. So let's say we have that kind of a graph. At this point, call it point A. Another point where the graph turns is at point B here. And another point where it turns is at point C, where it turns. So point A is called the point of inflection. Point B is the maximum point. And point C is the minimum point. So what do you realize if you look at the gradient, how the sign is changing, the sign of the gradient at the point of, or simply at the point of inflection, at the maximum point, and at the minimum point. You realize that when we talk at point A, you realize that the curve is sloping down, it levels out, then again it starts to slope down. That is at point A. So when it is sloping down, the gradient is negative. When it levels out, the gradient is 0. When it continues to slope down, the gradient is again negative. Or you may have a curve like this, it rises, levels out, then it continues to rise. When it is rising, the gradient is positive. When it levels out, it is 0. When it continues to rise again, the gradient is positive. When you have a graph of this form, then that point is called an inflection point. What about for the case of maximum point? At a maximum point, you see what is happening? The graph is rising. Then when it reaches point B, it levels out. Then it again falls. So it's rising, it levels out, then it falls. That is at a maximum point. So when it is rising, the gradient is positive, leveling out is 0, falling, the gradient is negative. So when you have, this is concave up, concave down, down, and that means it is a maximum point. When your graph is concave down, we talk about maximum point. And finally, look at the minimum point C. The curve is, before it approaches C, it is slowing down. When it is at C, it levels out, and just immediately after C, it continues to rise. So we have something like this at point C. That is concave up. The gradient, when it levels out, that is negative. Here we have 0. Here we have positive. So when you have a concave up, a graph that is concave up, we talk of a minimum point. So this is the point C. This is the point B. And this is the point A. It can either be this or this other one. So you see the nature of your graph at a turning point. That is when you're using the sign test to know whether your point is maximum, whether your point is minimum, or whether it is a point of inflection. Apart from the sign test, we could also use the second derivative test to determine the type of that turning point. So this one is sign test. Let me write here. Sign test for the turning point. This other side, I want us to look at the second derivative test. Second derivative test for a turning point. So we are going to say that let x naught, y naught be a turning point. On the curve y is equals to f of x. See the curve that we drew, I will have written here that y is equals to f of x. That's our curve. So let this be a turning point, x naught, y naught. How do you know whether that point is maximum, whether the point is minimum, or whether the point is a point of inflection? So the first one, when you want to test for a maximum point, let me use another color. If you want to know whether the point is maximum, you work out the second derivative of y with respect to x twice at the point where x is equals to x naught. If the value of that second derivative is less than 0, then it means we now talk of a maximum point. It means the point x naught, y naught is a maximum point. What about if the second derivative of y with respect to x twice at the same point x is equals to x naught is a value greater than 0, then what does it tell you? That that point x naught y naught is a minimum point. And finally, for the point of inflection, you test whether the second derivative of y with respect to x twice at the point where x is equals to x naught, the result is 0. If you get 0, then it means the point x naught y naught is a point of inflection. So very important. Usually it is better to use the second derivative test than the sign test. It's easier than the sign test. So then in summary, when you are finding the critical points or the turning points or the points where the curve turns, what you are calling the stationary points, there are only 4 steps that you need to follow. The first thing you need to do is to find the first derivative of the function, of the given function. The next thing you need to do is to equate the first derivative to 0 and solve the resulting equation to get the values of x. Once you have found the values of x, you substitute those values of x into the given function to get the corresponding values of y, so that you pair x and y to get the stationary point. And then you have to classify this turning point that you have found using the second derivative test. And remember, a turning point can be classified into 3 categories. You can talk of maximum point, you can talk of minimum point, or you can talk of a point of inflection. And I have told you how to classify such a point into those 3 categories. So let's look at an example of how to find and classify all the turning points on any given curve. So we're going to write example. Examples. You are told to find all the stationary points stock turning points on the following curves, and hence classify the points. Let's find the points and we classify them. We'll start with the simplest example. In part A, the simplest function is y is equals to x raised to 4. Let me write it. Y is equals to x raised to 4 plus 4x cubed minus 6. We're given that function. So as usual, let us find dy dx. So from here, the solution, let me choose another color. I can use green. So solution, you need to find dy dx is equals to 4x cubed plus 12x squared. Also find d squared y dx because we'll also need it. When you differentiate the first derivative, you'll get 12x squared plus 24x. So at any turning point, dy dx must be equal to 0. So at a turning point, we know that dy dx must be equal to 0. That means 4x cubed plus 12x squared must be equal to 0. And I can factorize this one. because I can see 4x squared is common, 4x squared into x plus 3 is equals to 0. So this means that therefore 4x squared is 0, which will give you x is 0, or x plus 3 is 0, which will give you x is negative 3. So that's what we have. So when x is 0, what is the value of y? So let me choose another color. So when x is 0, this means y is equals to, where there is x, we put 0, so that is 0 raised to 4 plus 4 times 0 cubed minus 6, and that is negative 6. So the point in this case is 0, negative 6. What about when x is negative 3? What will be y? Excuse me. So y will be negative 3 raised to 4 plus 4 times negative 3 cubed minus 6, and that should give us negative 33. So therefore, hence, our critical points are 0, negative 6, and another one is negative 3, negative 33. So those are the critical points, or the turning points, or the stationary points. Now we need to classify those points. So you can write classification. Let's start by classifying the first point at point PT will means a point at point 0, negative 6. What is d squared y dx squared? D squared y dx squared, what will be the value? That is when x is 0. Look at our second derivative here. So this is where you substitute x is equals to 0. So what are we going to get? We are going to get 12 times 0 squared plus 24 times 0, which is 0. And we said when the second derivative is 0, then it means this point here is an inflection point. Inflection point, because the second derivative is 0 at that point. Let's see the other point at point negative 3, negative 33. What is our second derivative? D squared y dx squared. Now you substitute x is equals to negative 3, so we'll have 12 times negative 3 squared plus 24 times negative 3. What will be the answer here? You can press that in your calculator. You're going to get 36 as your answer. Let me take this to the left and up. So the result here is negative, not negative, but positive 36, which is greater than 0. And we said when your second derivative is greater than 0, then it means the point is a minimum point. So this point is minimum point. So we have found the critical points, and we have also classified the points. I want to give you another example. On how to find critical points and also classify the points. So that was part A. In part B, let's say we have this function f of x is equals to 1 over 4x raised to 4 . 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 minus 1 over 3 x cubed minus 6x squared. We need to find the stationary points and also classify those points. Solution, in this case, let me take it up so that I have enough space to write the solution. So here, of course, we need to find f prime of x. That is x cubed minus x squared minus 12x. That is the first derivative. What about the second derivative? F double prime of x. That should give us 3x squared minus 2x minus 12. So now let's find the turning points. At a turning point, we know that dy over dx. You see, dy over dx is the same as writing f prime of x. That should be equal to 0. dy over dx is the same as f prime of x. So let's equate f prime of x to 0. What are we going to get? So we are saying that x cubed minus x squared minus 12x is equals to 0, of which I can factorize this so that you see x is common, x outside into x squared minus x minus 12 is equals to 0. So are we able to factorize this further? X squared minus x minus 12, that's quadratic expression. I need two numbers whose sum is -1 and whose product is -12. What is it that when I multiply, I get -12, and when I add, I get negative? So the numbers are -4 and 3. Those are the numbers. So we can now factorize x squared minus x minus 12 can now be written as x squared minus 4x plus 3x minus 12. When I group them into two, in the first group, I can see x is common, so that we have x minus 4. In the second group, 3 is common, we have x minus 4. So that can be written as x plus 3 into x minus 4. So go back to our expression here, our equation here. So we'll have x plus 3, x minus 4 is equals to 0. So from this equation, it is clear that either x is equals to 0 or x plus 3 is equals to 0, which means x is equals to -3, or another one, x minus 4 is equals to 0, which means x is equals to +4. So we need to find y when x is equals to 0. Let me write this in a column form so that I have a lot of space to find y. So we have either x is 0 or x plus 3 is 0, which means x is -3, or x minus 4 is 0, which means x is equals to +4. So when x is 0, what is y? Or simply f of x. Y and f of x are the same. So that will be 1 over 4 times 0 raised to 4 minus 1 over 3 times 0 cubed minus 6 times 0 squared. And the result there is 0 because x is 0. What about when x is negative 3? What will be y? So y here will be equal to 1 over 4 times negative 3 raised to 4 minus 1 over 3 times negative 3 cubed minus 6 times negative 3 squared. And so you can press that in your calculator. What are you going to find? Let's work it out. So just a minute. I also press in my calculator. We have 1 over 4, 1 divided by 4, and that is multiplying negative 3 and negative 3 raised to 4. Then minus 1 over 3 times negative 3 cubed. Then minus 6 times negative 3 squared. So you can press what have you found in your calculator. Negative 3. Let me press again. Raised to 4. This is raised to 4. Minus 1 over 3 times negative 3 raised to 3 minus 6 times negative 3 squared. The result is negative 99 over 4. Negative 99 over 4. And lastly, when x is 4, what is y? Y will be 1 over 4 into negative 3 raised to, not now negative, the x there is now 4. X is 4, so not negative 3. So this is 4 raised to 4 minus 1 over 3, 4 cubed minus 6, 4 squared. Let's again press that. So 1 over 4 times now 4 raised to 4 minus 1 over 3 times 4 raised to 3 minus 6 times 4 squared. The result there is negative 160 over 3. Negative 160 over 3. So therefore, what are the critical points? Therefore, our critical points are x is 0 and y is 0. Another point is x is negative 3 and y is negative 99 over 4. And finally, the other one is x is positive 4, y is negative 160 over 3. Those are the critical points. Let's classify these points into either maximum, minimum, or a point of inflection. So we are going to classify. I can write here classification. Of course, we use second derivative test. So look at our second derivative. That's what you're going to use, because already we have found it. F double prime of x. F double prime of x is this one. 3x squared minus 2x minus 12. So when x is 0, that is at point 0, 0. Let's start with point 0, 0. At point 0, 0. What do we have? F double prime when x is 0 is equals to 3 times 0 squared minus 2x, or x is 0, minus 12. And the result here is negative 12, which is a value less than 0. So what did we say? When your second derivative at a point is less than 0, then it means that point is maximum. So it means our point 0, 0 is the maximum point on that curve. Let's classify the other point at point. We have negative 3, negative 99 over 4. Let's see our second derivative, f double prime, when x is negative 3. The answer is 3 times negative 3 squared minus 2 times negative 3 minus 12. And we can also press this in our calculator. 3 times negative 3, and this is squared, minus 2 times negative 3, then minus 12. The result there is positive 21. I want to get 21, and this 21 is greater than 0. When the second derivative is greater than 0 at that point, then it means this point, negative 3, negative 99 over 4, is a minimum. It's a minimum point. And finally, let's see the other point at point 4. At point 4, negative 160 over 3. What will be our second derivative? So we write f double prime at x is equals to 4 is the same as 3 times 4 squared minus 2 times 4 minus 12. What will be our answer? Let's press in the calculator. That is 4 squared. The other one is 4. The result is 28. The result here is 28. 28 is also greater than 0. So this is another maximum, not maximum, but minimum point. You see, now we have two minimum points. The question is, can there be two minimum points? Yes. This is what we call absolute minimum and relative minimum. Those two minimum points, the smallest one is called, this one, we are going to call it relative minimum. And this other one is called absolute minimum. So that is the difference between the two minimum points. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you'll find me right there. Also, don't forget to share, to comment, and also to like this video. When we meet next time, we look at other applications of differential calculus. Bye-bye.